This week we are going to start some revision, ready for your check-in near the end of term. So today I'm going to go through you 4 questions on various different topics which are going to be in the check-in. So it's good if you have printed out, if possible, or written out the 4 questions that I've sent you, so that then you can do them along with me in this video. So if you haven't done that yet, just pause the video, make sure you're ready to get started. Okay, so question 1 is a surds question and a solving equations question. So it says solve x times 3 minus root 3 equals 30, given your answer in the form a plus b root 3, where a and b are positive integers. So to solve for x on this one, what you want to do first is make sure you get x by itself. So I could divide on this side by 3 minus root 3. Now, because there's a surd now on the bottom and we want to make sure that we don't have that in our answer, we need to rationalise the denominator. So I'm going to times by 3 add root 3 over 3 add root 3. This will give me on the top, so if I times the 30 by the 3 add root 3. And then on the bottom, if you remember when we do this, what happens is we end up just having the product of the first 2 terms, which would be 9, take away the product of the last 2 terms, which would be 3. That's because this becomes the difference of 2 squares and the root 3's will cancel each other out. Therefore I have 30 bracket 3 plus root 3 over 6. And the reason I just didn't multiply this out yet is just because I wanted to see if these would cancel, and they do. So 30 divided by 6 is 5. So I actually have 5 bracket 3 plus root 3. And then finally I could expand the bracket and get 15 plus 5 root 3. So now a and b are positive integers here. Okay, so I've set you some questions on practicing rationalising the denominator of a fraction with surds, and one other solve question like this. Okay, question 2. This is more about completing the square question to start off with. So it says express 4x squared take away 24x add 7 in the form p bracket x plus q squared add r, where p, q and r are integers. So if you ever get asked to express something in this form, it wants you to complete the square. Now you can see here that we've actually got a coefficient in front of x squared, the 4. So what I'm going to do first of all is I'm just going to factorise out that 4. Oh, sorry, just made a mistake there. I'm just going to factorise out the 4 from the 4x squared and the minus 24, but leave the add 7 at the end. When I fill that back in a minute, it would be what 24 divided by 4 is, which would be 6x. And then what you can do is complete the square on this part. So I just draw that in there. So if you complete the square on x squared take away 6x, it would be x take away 3 all squared. And then remember, when you complete the square, you've got to then take away this value squared. So 3 squared is 9, so you have to take away 9. And then again, you've got the add 7 on the end. And then what you can do is re-expand this bracket with the 4. So we get 4x take away 3 squared. Take away 36, add 7. And that then will leave us with minus 29 on the end. So now it is in completed the square form here. The part B says state the coordinates of the minimum point of y equals this. So if y now equals 4x squared take away 24x add 7, you could also say that y equals this, the completing the square form. And when you complete the square, this helps you to see the minimum point on your curve. So the minimum point will be the solution of this bracket, so for it to be equal 0, so it's always essentially the opposite of the value here. So because it's -3, x would be 3, and then the y value stays the same as -29. It's very similar to graph transformations, thinking about how this would move 3 across and then 29 down. That would get you to your minimum point. And then part C says, state the equation of the normal to the curve, y equals 4x squared minus 24x plus 7 at this minimum point. So if we think about now what the curve looks like, at 3 minus 29, so you know, somewhere down here we've got a minimum point, and because it's a positive quadratic, it's going to be something like this. Now I haven't actually figured out where exactly the these points are, but I'm just doing a little sketch here with the minimum point. So that's 3 minus 29. Now, because this is the minimum point, the normal to the curve at that point would be going straight down here. Because if you think about it, the tangent would be the one that touches the curve once there, which would be going across at y equals minus 29. So the normal, which is perpendicular to that, will be going straight through here, which will be the line x equals 3. And again, I've set you some questions as similar as I could find on completing the square and some minimum points and things like that. Okay, just 2 more to go. So number 3. So find and simplify the first 3 terms in the expansion of 3 take away 2x to the power of 5 in ascending powers of x. Now, with the binomial expansion, it's up to you how you do this. There's lots of different ways. But if you remember, this first of all, this 5, helps us determine the first number in all the terms. So the first term of the sequence would be 5, choose 0. The next one would be 5, choose 1. Then 5, choose 2. And it would carry on, but we only want the first 3 terms here. And then what happens is with the first value, the 3, we have it to the power of 5, then to the power of 4, then to the power of 3, and that would keep going until you got to the power of 0. And then the other part of the bracket would be going up the opposite way, so power 5 to power 0. So this would be minus 2x to the 0, which is just 1. So I'll write that in, but you don't need it because that will just equal 1. And then this would be minus 2x to the power 1. And this would be minus 2x to the power 2. So if we then figure this out, so 5 choose 0 is 1, and then we have to times it by 3 to the 5. If you can't remember, the choose button is here above the divide. So I could do 5 choose 0 equals, which is 1 times 3 to the power of 5, which is 243. Okay. And then for the next one, you do 5 choose 1 times 3 to the power of 4. And then you'd have to times it by minus 2, because it would just be to the power of 1, which is 810, sorry, x. And then the last one, 5 choose 2 times 3 cubed. And then minus 2x all squared. If you square all of it, it'll become 4x squared, so I need to times it by 4. So plus 1080x squared. Then for part B, it says, in the expansion of 1 plus ax squared times our previous one, the coefficient of x is minus 567. Find the value of a. So what we want to think about here is that if we were expanding this bracket, it would be 1 plus 2ax plus a squared x squared. And we're going to be timesing it by this expansion, which we've just started here. Which does carry on. Now it doesn't matter that we don't know all the terms because we're only interested in the coefficient of the x term. So when you're expanding this out, 1 times 243 wouldn't matter because that's not going to have an x in it. However, timesing 1 by minus 810x is important because that's got a coefficient next to x. If you times 1 by this term, again, it's not useful for us because it's got an x squared. So then we look at the 2ax term. Well, 2ax times 243, that's going to have an x in it. So if I just do 243 times 2, 486, I'm going to get 486ax. And then any of the other ones I do, that's going to become an x squared, x cubed. So they're not important. So these are the only two x terms, and we know that the coefficient of it should be minus 567. So I can write this equation out now to be true. You can cancel out the x's. And then you can solve for a. So a will be, if I bring that over there, 810 take away 567 over 486. Which is a half. So a must be 1/2. Okay, then the final one, so on polynomials. So the polynomial fx is defined by f of x equals 2x cubed plus 3x squared, take away 11x, take away 6. And first of all, we want to show that f of 2 equals 0. So this is called the factor theorem. So if 2 goes into this, we get 0, it means that x minus 2 is one of the factors. So I'm just going to do f of 2, and it would be, so I'm just going to literally put in x here as 2 for all of these. So 2 times 2 cubed, that's 3 times 2 squared, that's 11 times 2. Take away 6, so that would be 16, add 3 times 4, 12, take away 22, take away 6, which would be 28, take away 28, which is 0. And they do like you to show detailed reasoning on these ones, so it's quite good to write out all your steps. Then part 2 says solve the equation f of x equals 0. So if you now know that this is a factor, what that means is that x minus 2 must divide into the whole expression. So we need to do some polynomial division. Now the calculator will do this for you, but it does ask for detailed reasoning on this question. So if you remember how to do this, first of all you think about 2x cubed divided by x, which is 2x squared. And then you multiply this by the bracket to see what remainder we'll get. So when I times this by this, I'd get 2x cubed minus 4x squared. And then you take away to find a remainder. This will be 0. 3x squared take away negative 4x squared will give me a positive 7x squared. And then you bring down the next term. Okay, again, I'm going to divide 7x squared by x, which gives me 7x. Multiply it out, 7x squared minus 14x. 0 here, minus 11x minus negative 14x will leave us with 3x, and bring down that. Divide by x here, I get left with 3, multiplying it out. This is good because I've now got remainder 0. So I now know that f of x is the same as x minus 2 times all of this on top. And then I want to also factorise this last bracket. It's got to be 3 and 1 because 3 is a prime number, and I need the 7x, so it's going to go there, like that. So that means the values of x are 2, minus a half, and minus 3. Okay, and that's because it says solve it equals 0. Now the last bit says, hence solve the equation 2 sine cubed theta plus 3 sine cubed squared theta, take away 11 sine theta minus 6, well, I think that should say equals 0, sorry, for values of 0 to 360. Now what you've got to remember on this one is that this is the same equation as the one we've just solved. They've just swapped all the x's for signs. Otherwise it's exactly the same. So if we know the 3 solutions of the function of x are these 3, we could put sine theta equal to those 3 solutions. However, sine theta cannot equal 2, the sine curve comes between 1 and minus 1, can also not equal negative 3, so the only one we are going to solve is when it equals minus a half. So theta will equal arcsine of negative a half. So remember, you press shift, sine, and you get negative 30. Now negative 30 degrees is not in the window that we want. So what you want to think about is the sine curve. So I've got 90, 180, 270, 360, minus 90. And we've been solving for minus a half, so that's like this line here. So when you've put minus a half into the calculator, it's given you this value here, which is minus 30. Okay, just there. So the next time it hits the curve is actually going to be here, past 180. So we know that that gap is worth 30, so 180 plus 30 would be one solution, which is 210 degrees. And then you can see you've got another one here, just before 360. So it'll be 30 before, so take away 30, 330 degrees. So those are your 2 solutions that you could have there. And I couldn't find the exact same questions as these, but again, I have sent you some practice ones which will hopefully still be helpful. Okay, and just email me if you need any help, and on Thursday at 11 o'clock I'm going to do a drop-in session on Microsoft Teams, so if you can try and do your questions before then, and then if there's any that you get stuck on, you can ask me in person on the video call Thursday between 11 and 12.